My name is Flaki, and I'm going to be talking about WebAssembly extensibility, but particularly with JavaScript and Rust, because this is a Rust meetup after all, yes. So there we go. So as I said, my name is Flaki. That's the short version of István Smoczynski. I live in Estonia, Tallinn. You can see my Mastodon and Twitter notes. Feel free to ping me after the meetup anytime, and you will find me as Flaki on the Discord chat. I work at Suborbital, who it's really nice that we already had some folks talking about like server-side WebAssembly. We also do server-side WebAssembly. We at Suborbital we kind of focus on exploring the extensibility aspects of how you use WebAssembly to extend applications, or like kind of focus on creating applications per se. And I also am a co-founder of RustFest, and we have been doing a couple conferences. Maybe you've been to RustFest Global in the big P days, and we have been thinking about how to safely go back into in-person events and like figuring out how to make this all happen. So if you want to talk about Rust events and online events and Rust community, I'm happy to chat as well. And so if you don't have any like kind of like recollection or like knowledge about the history of WebAssembly, this question probably never crossed your mind, and then I would ask you to go like catch up on some of the WebAssembly history. I have a talk about this called the WebAssembly Field Guide, because like kind of like people have been talking about WebAssembly before, so I'm not going to go into this details super much. But basically, a lot of how WebAssembly will like kind of set a trajectory to why is it the way it is, and so a lot of that actually focuses on web browsers and stuff. So if you don't have any recollections of WebAssembly history, this question might not even be raised in your head, but like once you kind of like know a bit about WebAssembly and you know that it co-evolved with like other technologies, and it focuses on like kind of extending the browser functionality. A lot of people want WebAssembly to be something that will make like JavaScript go away in the browser. And what happened and like what was the intent from the creators of WebAssembly is more like remove the hegemony of like writing code in the browser from JavaScript. And like kind of provide an alternative and like work in collaboration with JavaScript. So if you have been heard, if you have heard people talking about that, like, but like now you're trying to put JavaScript into WebAssembly. Like, why would anybody want to do that? Like, why would you do that? So this image is from a blog post by Lynn Clark on the basically running JavaScript inside WebAssembly and making it actually fast. Because like making it like fast is like the first step is like, okay, that you can put JavaScript into WebAssembly, but if it's going to be just slow, then like why would you do that? Like if you can at least make it fast or like fast enough, that's like already can break up some of the skepticism. So if you're interested in how to do that in particular, then go read the blog post. It's wonderful. It's long. It's a really good cartoon deep dive into the whole concept of like why would you need or like how would you put JavaScript in there. But like as for why would you need it, like first of all, you have WebAssembly, and WebAssembly has all of these like nice properties. Then you want to use it for things, and like some of those properties even put it past what is possible with just JavaScript in terms of sandboxing or security or a lot of that stuff. So you can't just like there are technologies that use JavaScript on like a kind of high performance cloud environment today, that use like JavaScript isolates, for example, or similar technologies that basically is like use the WebAssembly virtual machine as like a high performance executor of code. And I would say like WebAssembly is probably a competitor in that field, or WebAssembly is a technology that can be used for similar things. And like our friends at Fermion, or like us at Suborbital, and a bunch of others have been working on like kind of exploring this problem space. So there's a blog post again. Like, I'm not going to talk super much about like why would you want to run WebAssembly on the server, but like basically WebAssembly provides us an opportunity to, as Radu also mentioned, is like kind of create with really high performance, really low startup time, like cold start time, tiny modules that you can plug into your ecosystem, like besides your existing applications and existing containers and cloud infrastructure, and like kind of expand what is possible to do, or reduce costs, or something like that. So okay, so now we get it. Like you can put JavaScript into WebAssembly. You can run WebAssembly in a server side, and you might even want to do that, like because like that might give you some advantages. But like, why would you put JavaScript on a web server if you could just use like Node.js or whatever on the server side? And so I mean, at least our argument, or like biggest argument, is basically extensibility and the fact that people really like JavaScript. Like people like them script languages, and JavaScript is one of the most, I don't want to put like, what is that, Gartner images in here that says JavaScript most popular language of the internet, like 6 years in. Anyway, so people really like their JavaScript, and it has a lot really low like kind of friction, especially if you already know JavaScript. But like all scripting languages have like a really low friction. So I guess you can always, as Radu mentioned before, Rust has super support, and like we support like a Suborbital compiling your WebAssembly modules from Rust. But why did we need like JavaScript? It's because if you already know JavaScript, it's just going to make it so much easier for you to get started. You don't have to learn Rust or whatever other language to compile to C, to WebAssembly, or C or Rust or something to compile to WebAssembly, and then finally you can use it in the cloud. And how we do that is an interesting question, rather than why we do that. Like there is demand basically from people wanting us to do this. So how do we do this? There is a excellent talk from the Shopify engineers, how and why they built Javi, which is a JavaScript in WebAssembly engine, for this exact use case. And you'll find a lot of pointers in the talk, but basically what they use WebAssembly is they took the WebAssembly runtime, chucked it into their own infrastructure, and rather than worrying about like webhooks or plugins or DLLs or whatever extensions that are a security problem and like a performance issue, they can put a high performance language, a high performance runtime into the Shopify ecosystem, and basically use that to say, hey, people, here's a thing. You can create WebAssembly modules and like put that right into our infrastructure to modify some part of the infrastructure that you use. So Java is actually written in Rust. It embeds basically a tiny JavaScript engine and compiles it like wholesale into WebAssembly. So you're running a WebAssembly engine, like a WebAssembly compiled JavaScript engine inside your WebAssembly code, which is like like multiple levels of like abstraction. We have to go deeper. And so this is also what we use at Suborbital to put these WebAssembly code into our infrastructure and allow people to run JavaScript in WebAssembly by using Rust tools. And like Java is already a Rust tool that I mentioned, but there is a ton of Rust tooling around the WebAssembly ecosystem that we also use. There is a there's a proposal. I believe Radu already mentioned it in his talk, and he has a great blog post about like WebAssembly components. What is the key underlying component of WebAssembly components is interface types and like the ecosystem it enables. But basically, like we're using WebAssembly interface types and a Rust project called vidbindgen to automatically generate bindings to give you superpowers like access network requests, or I don't know, access the file system, give you things that basically break like limited breakout of the sandbox, because normally WebAssembly wouldn't be able to access anything. So that would be a very useless thing, like to be able to run WebAssembly on the edge and not be able to do anything with it, right? Number crunching, basically. Here you can basically give WebAssembly superpowers. So you can, fetch an API call or something like that. And so there's a ton of underlying Rust projects that basically enable a whole ecosystem, including putting JavaScript into WebAssembly and compiling a whole engine into WebAssembly. I'm not going to go even further than that because I'm running out of time, but I also posted a really cool explanation by Oscar Spencer, our director of engineering, who goes into the depths of how we hacked around like with bindgen and like kind of generate all our bindings using automatically using our API definitions, and like using that to give you a JavaScript engine running in WebAssembly. And basically, at the end of the day, a lot of the WebAssembly functions, basically starting because of the startup times and stuff. A lot of the WebAssembly functions are short-lived. You have a tiny under sub-millisecond instantiation, and a lot of the times they are not doing anything super, performance intensive. Like a lot of the times, especially with WebAssembly components coming, you can plug together, for example, a very simple access to a remote API, and use JavaScript for that particular thing in your WebAssembly code. And if you have, like, for example, an image transcoding task or something, you can just compile a Rust module into WebAssembly and use that for the added performance benefits. And so you can always use the best tool, the best tool that gives you, I really am becoming Gartner, the best velocity to your teams. So again, like, check Oscar's talk if you want to learn more about that. And check out Nick Fitzgerald's talk, who also is a creator of some of the, I would say, one of the most important part of like why running a JavaScript engine in WebAssembly is possible. And the most important part of like why is this possible without losing the big benefit of like WebAssembly being able to instantiate in like sub-milliseconds. And basically that's because of like the snapshotting that Wiser, the tool that is built by the Bytecode Alliance and Nick Fitzgerald in particular allows. And so again, like you will see Wiser mentioned in Link Lark's talk as well, and like you will see a full presentation of how it works. But basically, this is like a fundamental thing that enables like quick starter times, even for a complex thing like compiling an entire JavaScript engine into WebAssembly. So check that one out if you're interested in more details. And thank you so much. If you have any questions, I'm super happy to answer in Discord, and you'll find hopefully the QR code works, but I'll post the slides link into Discord as well.